Okay, lesson on sequences, the first one on chapter 3, sequences, lesson 1. Okay, so today's lesson is on arithmetic sequences. And by the way, there are going to be some clues in this video, 6 clues, all on. Let me start that again. Hi, Year 12, and welcome to your first lesson on sequences. Okay, to make it a little bit more fun, each video is going to have a little competition. This one, there are 10 animals hidden in my video, either written or spoken. You need to find all 10, and the first person to email me gets a magnificent prize. I would like you all to find these animals and email them to your teacher as you are doing the work. This is going to check that you're all watching my videos. Okay, and first person, a super duper prize. Okay, right, so today's lesson is on what we call arithmetic sequences, which you would have come across in GCSE. Right, arithmetic sequences are sequences, for example, like this one, which goes up in twos from one term to the next. So from one term to the next, you're seeing we're adding 2 each time. Or the sequence could be going down. And in this case, from one term to the next, it's going down, in this case, in threes. So if a sequence is going up or down, with a constant, what we call difference between each term, this is called an arithmetic sequence. So I would like you to write this into your book, please, into your notes. If the difference between each term is constant, you have an arithmetic sequence. Little hint here, your first animal. Okay. So, what are we going to do with arithmetic sequences? Right, well, if you've got, for example, this is saying that the nth term, so UN stands for nth term. In this case, we're saying the nth term is this, where n is the value of the term, i.e. n equals 1 for the first term, n equals 2 for the second term, n equals 3 for the third term. So what we're going to do now is find the first term, the second term, and the third term. So for the first term, you say it's 34 minus what n is 1, so 3 times 1. So 34 minus 3 is 31. So the second term will be 34 minus 3 times 2, putting n equals 2 into here. So 34 minus 6 will be 28. And the third term, 34 minus 3 times 3, 34, take away 9, which will be 25. You can see from one term to the next, we're going down in threes. Okay, now my next question is find the first term in the sequence that is negative, i.e. is less than 0. So what you're solving is this. You're solving when is the sequence, the value of n for this to be, just cross that out, just written that down twice. The value of n for which this will be negative. Okay, so if I solve this inequality, add 3n to both sides, divide both sides by 3. So n has got to be bigger than 34 over 3. So reading this way, n reading from right to left, n is greater than 34 over 3. i.e. n is greater than 11 1/3. So the first term for which the sequence is negative, well, the first, obviously n has to be an integer, okay, because it's the value of the term. So the first value to make the term negative will be when n is 12. If I was to put n equals 12 into my formula, so this is my formula for the nth term. When n is 12, so the 12th term, I get 3 times 12, 36, which is negative. The first term that is negative. If I put in 11, I will not get a negative number because I will have 1. So 12 is the first term that will be negative. Okay, so let's look at another example of arithmetic sequences. Right, so here, example 2, you have a sequence and we want to find the nth term. Right, before we do that, I want to show you a proof of a formula for the nth term of an arithmetic sequence. And once I've gone through this, I want you to pause and write this into your books. Okay, if we call A the first term and D the common difference. Now, in maths, we always use A for the first term and D for the common difference. So if we look at our sequence, A is the first term and the next term will be A plus whatever the difference was. For example, say I had this as my sequence: 1, 4, 7, 10, 13, 16. It's going up in threes, yeah? So A is 1 and D is 3. So my first term is 1. My second term is 1 plus 3, 1 plus D. What would my third term be? Well, here I'm adding another D, so it's 1 plus 2 lots of 3. Each time I'm adding D on. So my next term will be A plus 2 lots of D. My next term after that will be A plus 3 lots of D, etc. So the difference between each term, you can see we're adding D each time. Okay, so I'm just going to let the cat out of the house. No, the cat's fine. No, she stopped scratching. Okay, so what we have got then, if I just write this out again a bit clearer: first term, second term, third term, fourth term, and it carries on. So first term, second term, third term, fourth term for an arithmetic sequence. Now, I want to find a rule for the nth term. Okay, well, I'm sure you can see that already, yeah? So if say, for example, I wanted to find what the 10th term is. Well, the 10th term will be A plus how many D's? Well, it's going to be 9 lots of D, yeah? 1 less than the term itself. So the fourth term is 3 lots of D's. The third term is 2 lots of D's. The second term is 1 lot of D. So the 10th term would be A plus 9D. So the nth term would be A plus n minus 1 D. For example, the 100th term would be A plus 99D, 1 less than the term itself. Okay, so I want you to write down this expression here, please, for the nth term. And I want you to write this down as well of how we worked it out. Okay, so pause and write that down, please. Okay. So, if I've got this as my sequence here, I can see that my nth term, let's just always write down the rule first, is a plus n minus 1d. So in this case, my first term is 4, and it's going up, each term goes up plus 5. Yeah, it's going up in 5s. So 4 plus 5 lots of n minus 1, d is 5. So if I was to expand that, I will have 4 plus 5n minus 5, or 5n minus 1. Now at GCSE, you worked out the nth term in a different way, but for A-level, we're going to use this formula here. Okay, what about if my sequence was going down? Well, in this case, my first term is 80, and my common difference is going to be negative 3 because it's going down in 3s from one term to the next. So, my nth term, what will an expression for this be? Well, let's just write the formula out again. So, a plus n minus 1 times negative 3. Be careful with the negative 3. So 80 minus 3 times n minus 3 times 1, or 83 take away 3n. My nth term. Okay, write down those into your book. Right, let's get on to something a little bit harder now. Example 3. In an AP, that's another word, that's a shorthand for arithmetic progression or arithmetic sequence. The third term is 5 and the 8th term is 20. Find the rule for the nth term. Okay, so we're not given the first term here, are we? So what have I got? Well, I've got the third term, which we can write like this. Third term is a plus n minus 1d. Now, the third term, n would be 3, so I've got 2d. And we know the value of this, of the third term, is 5. Okay, so can you now write an expression for the 8th term, please? Pause and have a go. So the 8th term will be a plus 7d, because n is 8, and this will equal 20. So you can see now I've got two equations with two unknowns, a and d. Because it's the same sequence, so a and d will be the same. Right, how am I going to solve this? Well, I'm going to solve this using simultaneous equations. I'm going to do 2 take away 1. So a's will cancel. 7d take away 2d. 20 take away 5. So I get d to equal 3. Okay, let's sub that back into my first equation. So a plus 2d equals 5. 2 times 3 is 6. So a is negative 1. So so looking back at the question, find the rule for the nth term. So my rule will be a minus 1 plus n minus 1 times 3. So here is my answer. And you can expand that out. Okay, let's look at example 4. Find the number of terms in this sequence. Find the number of terms in each sequence. So, to do this one, we are going to work out, first of all, my first term is 5. My common difference is going up in 3s. Now, this is my last term. So my last term is a plus n minus 1d. So n is the number of terms in this sequence because this is my last term. So my last term is a plus n minus 1d. So if I solve this, I will find my value of n, and that will be the number of terms. So 122 is 5 plus 3n minus 3, or 3n plus 2. So I'm going to take away 2 from both sides. So n will equal 40. Okay, so there are 40 terms in this sequence. Okay, pause the video and have a look at this one here, example B. A little bit harder, but have a go to find the number of terms in this sequence using the same method. Okay, let's see how you got on with that. So, my first term in this case is a constant p. Don't know what p is. My common difference is going up in 3p's. Yeah, 4p take away p is 3p. We're adding 3p each time. My last term is 31p. So we know that 31p is a plus n minus 1d, where n is the number of terms in my sequence. So, let's substitute in. My first term is p. We want to find n, and my common difference is 3p. So I've just substituted these here. Right, let's multiply out now and simplify to find n. So this will be 3pn minus 3p. Let's take all my p's to the one side. So that'll be plus 2p equals 3pn. So I've got 33p equals 3pn. And now let's just divide both sides by 3p and we get n, which would be 11 because my p's would cancel. So we've got 11 terms in that sequence. Okay, well done if you got that right. Right, next question. Next part. I'm going to look now at some harder questions. Okay, I'm going to look at this one here. Page 62, exercise 3A. Have a go first, pause the video, and let's see how you get on. An arithmetic progression has these as its first 3 terms. First term, second term, third term. Find the 2 possible values of k. 2 possible values. Now, I know that it's going up a common difference d. Yeah? That common difference is the same. So I know that if I do k squared minus negative 8, that would be exactly the same of 17k take away k squared. So the difference is going up will be the same. So the first difference is this. The difference between each term. The second term take away the first term. That must be the same as the third term take away the second term, because the difference between each term is the same. So now I've set myself up an equation in k, but it's this step that is the tricky bit, the understanding of this step here. So let's just now solve this. So you can see you've got a quadratic equation. I'm just going to take everything to the one side. We get that. Now, I'm sure this will factorise. Let's just see. Okay, so I'm going to have 8 here and 1 here, and both negatives. So k is a half, or k equals 8. A top tip here is that you can use, just use your calculator to solve this, okay? Now, if you're not sure how to use your calculator, please email me on how to solve a quadratic equation. As long as you must show your method as well to the examiner in the GCSE exam, but always use your calculator to make sure your answers are the same as your calculator. Really key, that is. Right, okay, so that was that question. Let's look at another one. Okay. Right, question 10 in exercise 3A. Have a go at it and then see how well you do. So I've chosen some harder ones here for you to have a go at. So first term is k squared, the common difference is k, and the fifth term is 41. So a plus 4d, the fifth term. So if I use this, okay, and substitute in a and d, let's see what happens. So 41 is my first term plus 4 lots of my common difference. So a was k squared, d is k. I'll just sub those in. Okay, so I've got a quadratic equation again. Let's move it all to one side to make it equal to 0, so I can solve it. Now if we go back to here, they can see k was not a whole number. So this is not going to factorise. I'm not even going to try and factorise it. How would you solve this? Well, there's two ways. You can either use the formula, x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a, or you can complete the square. Much easier to complete the square in this case because there's no coefficient here in front of the k squared. So k plus 2, half the difference, squared, take away 2 squared, take away 41 equals 0. So let's just solve for k. So k plus 2 will equal plus or minus root 45, which if I simplify that third will be plus or minus 9 times 5. 9 is a square number, so plus or minus 3 root 5, simplifying a third. So k is negative 2 plus or minus 3 root 5. Let's just compare that to what you were asked to put your answer into. You were asked to say k is p plus q root 5, where p and q are integers. So I can see p is negative 2 and q in this case must be plus 3. K cannot be, I'm just thinking, k cannot be negative. It's not a negative value, so this must be positive 3. So we only have positive 3 here. Okay, and my very last question is the challenge question. Have a go. Okay, super tough, this one. Super, super, super tough. Have a go, and I'll go through the solution now. Right, so you've got your expression for the nth term. You're told the 3rd term and the 7th term, and you want to find A and B. Much harder because we've got ln, the inverse function of E. So what we're going to do here, we're going to set up 2 equations. So the 3rd term, term 3. Let's substitute n equals 3 into here. So n equals 3, so 3 minus 1 is this. And we know the answer is ln 16. Okay, what I'm going to do now is use my rules of logarithms to combine this into one ln. So this is ln A plus ln B squared, which is the same as ln A times B squared, using my rule of logarithms. Now, obviously, ln of something is the same as ln of 16. That means that AB squared must be 16. So I've got one equation with A and B. Now I'm going to do exactly the same for the 7th term. So have a go yourself if you didn't do this. So the 7th term, we're going to put n equals 7. So this would be here into my original expression for the nth term, bunging n equals 7 into here. And we know the answer is 256, ln, of 256. Right, let's do exactly the same as what we did for the first one. And we get this. Okay, now, exactly the same as before, I'm going to get another equation. AB to the power of 6 is 256. So I've got 2 equations, 2 unknowns, so I can solve it. Let's see how we're going to solve that. I'm going to write the second equation underneath here. Right, in this case, I'm not adding or subtracting, I'm going to divide. Okay, you can do that. I'm going to divide this side by this side. So my A's will cancel, and I'll have B to the power of 4. When I'm dividing, I take away the indices. And 256 divided by 16 will give me, let me just think about that for a second, will give me 16. So I'm doing this divided by this will give me 16. So using your calculator, B must be equal to 2. 2 to the power of 4 is 16. So I've got B, now let's just find A. So I'm going to sub it back into here. A times 4 is 16 because B was 2, so A equals 4. So I've got my 2 answers for A and B. Well done if you did that on your own. Right, let's speed it up a little bit now, guys. Okay, so here is your work for today. Okay, I hope you got those 10 animals. There was one that was said during my video. The cunning ones amongst you will know what that is. Don't worry about any optional work for the moment. Okay, have a lovely day and email me questions you're not sure about, guys, because that's the only way it's going to get any better. Bye-bye.